in this lecture we are going to learn about IP addresses. Okay, so this is a buzzword that we always hear. What is the IP address of this machine? What is the IP address of your mobile, and so on. Okay, so we will study here about IP addresses and we will know what does it mean. So let's try to see. So upon completion of this lecture, so first thing is that you will understand the IPv4 addresses and the classes of IPv4 addresses. Okay, then you will understand how to find the class of an IP address, find the network address of a given IP address, and what are the network masks. Okay, this thing also you will hear a lot, and know how to use them, understand subnets and supernets. Okay, so this is in short what you will get from this lecture. Okay, so we will proceed. So what is an IP address? So it's an identifier in a TCP IP protocol where each device on the network gets a unique IP address. Okay, and this IP address is basically a 32-bit number. Okay, so there are many computers on this earth. Okay, and they are all connected. So now when similar to people, there are many people in a room. So to what we give in a classroom also, we have students with roll numbers. Okay, so that we can uniquely identify them. Okay, so similarly in the internet you have many machines, and to uniquely identify each machine we give a 32-bit number to them, which is unique and universal. Okay, two devices on the internet can never have the same address. Okay, because if we want to send some packet to this one, so if two computers have the same name or IP address, there will be ambiguity about which of them to send, and we don't want that. Okay, so that is there. So let's move forward. So IP address is a 32-bit address. So what is the size of IP address? So it's a 32-bit number, and IP addresses are unique, what we saw. And how much is that 32-bit? Okay, so 32-bit, so you have bits like 001, 101, this till 32. Okay, so if you have 32-bit number, you will have 2 to the power of 32 IP address. Okay, which is quite large, but because the number of computers are increasing rapidly and exponentially, so even this number has become less to represent all the machines uniquely. Okay, so that's why now we also have IPv6, but for now we will look at IPv4. Now let's try to see the dotted decimal notation, which is the most usual notation of IP address. So we have this number, if you see here, 128.11.3.31. So this is a human readable format of IP address. And what happens? You have 32 bits, or basically 4 bytes. So this is the first byte, this is the second byte, third byte, and fourth byte. And we separate them using dotted decimal notation. So in actual, the 32-bit number is, first one is 10000000. Okay, so this number is nothing but 128. Okay, then we have, this is 11, and if you see this number, just we will try to look here. So this is 11, and if you see, this is 2 to the power of 0 plus 2 to the power of 1 plus 2, 0 into 2 square plus 2 cube. So 8 plus 2 plus 1, which is 11. Okay, so this is representing, this next 1 byte is representing 11. Then we have 3, so you have 1 which is 3, and then we have this 31. So all the last 5 bits are 1, which represents 31. So we have the dotted decimal notation. So these are 32 bits. Okay, we take a group of 8 bits at a time and put it in decimal, dotted decimal form. Okay, so next We will try some examples. Okay, change the following IP addresses from binary notation to, so these are the binary notations. Okay, and we want to convert it to, okay, the IP address dotted decimal notation. So let's try out ourselves. Okay, so this is a kind of small quiz to make our concept very clear. So this is the first question. These are the 8 bits group, and let's try to see it. So this first one is 2 to the power of 0, and this is 2 to the power of 7. So 2 to the power of 7 plus 2 to the power of 0. So which is 128 plus 1. So 129, this number is 129. This is 1 plus 2, 3, 3 plus. So this is 1 plus 2 plus 8. So this is 11. This number is 11. This is 1 plus 2 plus 8. Again 11. This is a big number. Okay. So this, if you want to see, so this is, let's try out, this is 2 to the power of 0. So 1 plus 2 plus 4 plus 8 plus 16 is not there, 32 plus 64 plus 128. Okay, so this is a big number. So 64, 32, and then we have 8, 4, 2, 1. So 8, 4, 12, 12, 14, 14, 22, 26, 28, 29, 2, so 6, 10, 13, so 239, I think. So I have a kind of mess of calculation here. So 239. So this, if this is 239, okay, and I think the calculation is correct. So this is 129.11.11.239. okay. So similarly you can find these again. Okay, so these numbers, okay, and how you, just for your knowledge, if you want to have a binary, so to find this binary, what we do, this is 2 to the power of 0, this is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, and so on. Okay, so 1, this is 1 into 2 to the power of 0 plus 0 into 2 to the power of 1 plus 0 into 2 square plus 1 into 2 cube plus 1 into 2 to the power of 4, 1 into 2 to the power of 5, 1 into 2 to the power of 6 plus 1 into 2 to the power of 7. Okay, so this is how you represent. So let's try to see some more answers. Okay, so we see that the answer is, okay, so the 129.11.11, and then we have 239. Okay, so this is our answer, which is correct. So we can try out others also, but I hope you understand that. So let's move forward. Next question is just a small quiz again to get your concepts right. Find the error, if any, in the following IP address. So is there any error? Let's try to see. So this is 111.56.45.78. Is there any error? So 111, 8 bits, we have 8 bits in each, so each of these dotted decimals should not be more than 255. Okay, so their range is 0 to 255 because they are all 8-bit numbers. So 111 is fine, 56 is fine, 45 is also in this range, 78 in this range. So you will think it's correct, but the thing is 045, there is no need to write like this. So this is the error, 0 should not be there. Okay, so I think let's check out the answer. So there are no leading zeros in the, so 045, there should be no leading 0. So we are correct, bingo. Next we see 221.34.7.8.20. okay, so we have 32-bit address IPv4. Now here you have 5 dotted numbers. Okay, so this is not correct, it's in fact 40 bits. So you are wrong here, and that the number of bits is 40. So this is incorrect. So let's try to check it. We may not have more than 4 numbers in the IP address dotted numbers because it's more than 32 bits. Let's try to see the next one. So 75.45.301.14, here the thing is, this byte, it's more than 8 bits. Okay, 255 is the highest number you can represent using 8 bits. This is 301. So this is also wrong because of this particular reason. So we see that in dotted decimal notation, each number is less than or equal to 255. 301 is obviously out of range. This number is, again, so it's pretty simple. You cannot have a binary here. You should represent using a decimal. Okay, and that's, I think, is there a mixture of binary notation and dotted decimal is not. Please correct. Okay. Now we will see address space. For we have here, what we are going to see is classes of IP address. So we have 4 classes: A, B, C, D and E. Okay, and these pictures are basically representing the number of IP addresses in each one. We saw that we have 2 to the power of 32 addresses total. Okay, half of it is taken by class A address, because class A address, the thing is, it starts with a bit 1, first bit as 1, next bits can be anything. So this is for class A, 1 followed by anything. B is, okay, so this is 0 followed by anything. B is 1, 0. Okay, so we will look at it. Okay, so we will look at the rule. So class A, you have first byte, in that the first bit is 0. In class B it's 1 0, class C it's 1 1 0, class D is 1 1 1 0, class E is 1 1 1 1. Okay, so now you will say, why do we have these many numbers in class A, class B and so on? Okay, so you will see that the prefix of each one of them is different. Class A, you can directly know no class A address will belong to any other address. So I will show you this thing. So we have class A starts with 0. You have 31 bits remaining which can have any value. So we have in class A 2 to the power of 31 addresses. First 2 bits of class B are 1 and 0, which is unique, different from this. The rest of the bits left is 2 to the power of 30. Okay, which can be seen here. And 2 to the power of 31 is twice of this. Then we have 3 bits here taken. So it is 2 to the power of 29. As can be seen from this. Class D, you have 1 1 1 0. Okay, so this is now 2 to the power of 28. Class E is again 2 to the power of 28 addresses. So now the thing is, this is the highest number of addresses in class A is highest, which is 50%. This is half, so 25, again half of that, 12.5. These two are 6.25. So I hope this is okay for you. Now let's try to see how we will identify. So any class IP address, if you want to identify its class, so what you need to do is identify the first bits of it. Okay, first 4 bits kind of thing. Okay, so let's try to see. So you start, this is the algorithm, okay, animated algorithm. So you start with the IP addresses, okay, and see if the first bit is 0. If it is 0, it's class A for sure. Okay, but if it is 1, then you proceed. Let's check the second bit. If it is 0, then it is class B. If it is 1, we cannot say right now what it is. Now again, if third bit is 0, so it means 1 1 0, then it is class C. But if it is 1, we proceed further. So 1 1 1 and fourth bit is 0, then it is class D. But if it is 1, then we have 1 1 1 1, which is class C. So this is the simple algorithm for class E address. So we will now use our algorithm here. Okay, so find the class of each address. So let's try to see. So what is there? This has a first bit at 0. So this is class A address. First bit is 1. So we proceed to second bit. This is also 1. So it means it's not class A, not class B. 1 1 0. So this is, I think, based on our previous algorithm, this will be class C. So let's try to check it out. So the first bit is 0, this is class A. Okay, the next one, the first two bits are 1, the third bit is 0, so this is class C address 11010. Okay, so this is when you have 1 followed by a 0, first two bits is 10, it is class B. If you check here, class B, and then the last one 1111, it is class E. Okay, so we are done with this one also. So this is the idea, class A. Now let's try to look in terms of numbers or in the dotted decimal. So if you have class A, it will be from 0 to 127, the first byte, and then class B is from 128 to 191, class C is from 192 to 223, class D from 224 to 239, class E 240 to 255. Now again a test. Okay, every time we read something we have a test. 227.12.14.87. so what is this address? So this is addresses, now it is class D. Okay, let's try to check. The first byte is 227, between 224 to 239 it is class D, which was seen previously. Next one, okay, I have shown you the answer. 193.14.56.22, check out this first one. 193 belongs to class C. Next one, 14.23, this is 0 to 127, this is class A address. Okay, and then we have 252 dot something, so it is class E. Okay, and final one is 134, so it belongs to class B. Okay, so we have done with our lecture on IP addresses, and we learnt about classes, how the IP address, the dotted notation. I hope you understand this. Thanks a lot.